Hello, my name is Nat, and I'll be your interviewer today.
Hello, my name, Endo. Last name, Thermic. Was it my given name? Yeah, it was. Did I have a choice? No, my father's name was Exo, last name Thermic. That's how I got Thermic. My mother's name was Glucose, who knows what, but now it's Glucose Thermic. So here I'm endothermic with my buddy here.
G'day, mate. I'm Mitochondrian Mike, and I'm here to talk to you about. What are we talking about again?
We are talking about cell respiration, Mike.
Cellular respiration.
So, can one of you tell me what are the 4 steps of cell respiration and where does each take place?
Okay, cameraman, what's your name?
My name is Nate.
Yeah, I don't care. Okay, step 1, we have glycolysis. Following that, we have the transition step. Then step 2 is the citric acid cycle. That reminds me of some nice orange juice on a summer hot day. Step 3 is electron transport and chemolysis. I probably pronounced that wrong, but I don't give a crap. Anyway, step 1 takes place in the cytoplasm. And the next 3 steps, the transition step 2 and step 3, take place in ETS.
Show me and tell me where glycolysis takes place.
Hello, mate. So, I'm here to talk about glycolysis. So, what does glycolysis mean? Glycolysis means the breaking apart of glucose. Do you understand that? I'm sure you do. Right, so as you can see here, we've got the diagram, right? So, you've got, what is this? 6 carbons, right? And they're going to come down, and then they're going to be broken into 2 sets of 3 carbons. And then they're going to reduce, and come down here. And throughout the process, you're losing some things, like in step 9 here, you're losing some H2O, right? And perhaps some NAD plus comes in or out, or ADP, right? But at the very end, you're going to come off with the products of NADH and something else. Yes, 2 ATPs.
Explain how many ATPs are used and how many ATPs are produced during glycolysis.
Well, I want to make something clear to start off, okay? I do not want to be here. I was forced. My father forced me into this service because, you know what? I was born with a great brain that has knowledgeable. I might as well put it to use and not just sit like a couch potato like Mrs. Cameraman here, like I know she always does. Anyway.
This is also court-ordered community service for her.
Oh, yes, I have to do community service because I've done stuff to, we don't need to get into it. Anyway, so what was the question?
She killed a pelican by strangling it. It was brutal. It was on the news.
Oh, I did not strangle it. He did. He was the one who blamed me. Anyway, okay. So, there are 2 ATP that are used in glycolysis, and 4 of them are produced. So you know what? That's the only way, no other way.
What are NADH and how many are produced during glycolysis?
Alright, so NADHs are electron carrier molecules. They are produced both during glycolysis and the citric acid cycle.
Next question. Show and tell me where and how transition takes place.
Alright, so I'm here to talk about the transition step. So there's a few important things about the transition step. 1, it's an exothermic reaction. 2, there is a net gain of 2 NADHs. And 3, it takes place within the mitochondria. The interesting thing about this step is it's sort of a step, sort of not. Its purpose is to connect the glycolysis to the citric acid. Its purpose is to connect glycolysis to the citric acid cycle.
How many NADH are produced during transition? And how many CO2s are released?
Okay, so the transition phase. 2 NADH are produced and 2 oxygen are released. Whee!
Keep in mind, if she were not here, she would be in rehab right now.
Show and tell me where and how the citric acid cycle takes place.
Right, as you can see, my colleague's currently sleeping, so I'm going to be doing this step. Right, so we're going to talk about the citric acid cycle. Shh, rest now. There'll be time for you later. Alright, so here's a few interesting things about the citric acid cycle. The net gain is 6 NADH 2 FADH and 2 GTP, right? So here's how it works. You have 2 carbons, you want to get 4 carbons from another part of the step, right? And they're going to come down, and you're going to have NADH be produced along with some other things, right? And then, some carbon dioxide come off, right? So it's going to go down here, go down here, go down here, right? And it's going to produce a half a sugar. So you need the cycle to go twice to produce a full sugar, right? So then the remaining things that weren't used to produce the sugar, the carbons, are going to come back up through the cycle, and they'll do some little adventures of their own, perhaps producing the FADH2, right? But then the 4 remaining ones will come back up here and then be reinvested into the cycle for it to start again.
How many NADH, FADH2, and GTP are produced during the citric acid cycle?
That was a wonderful sleep. Anyway, back to science. So, 3 NADH, 1 FADH2, and 1 GTP, which can also be converted into ATP, are produced per cycle in the citric acid cycle.
How many CO2s are released from the citric acid cycle?
So during the citric acid cycle, 2 carbon dioxides are released.
Show and tell me where and how ETS takes place.
G'day, mate. So I'm here to talk to you about the electron transport chain. Alright, so first things first, where does it take place?
Where?
That's a good question. It takes place within the mitochondrion.
Mitochondria.
The mitochondrion. Right. Now, you might be wondering how this whole step takes place, right?
How?
The most important thing to remember, right, is these little guys, the electrons, right? Now, here's the thing about the mitochondria. On the inside, there is a low proton concentration. On the outside, there is a high.
Ooh.
Yeah. All right. And there's this little miracle cell here. It's called an ATP synthesis. All right.
Beautiful.
So here's what's happening, right? You have the little electrons, these little E's here, and they're gonna run all along. They're gonna run, and do their thing, right? They do their thing, right?
Mm-hmm.
Now, once they're essentially powering these places, protons can come, they can migrate from the high concentration to the low concentration, because that's what protons like to do, right?
Yeah.
A general migration. But as they go through the synthase, what's going to happen is it's going to produce ATP, right? Which in the end, it's going to leave us with a few things. The main thing is there will be 6 NADH and 2 FADH
2
at the very end as our end products.
Explain how the NADH and the FADH2 from the previous steps are used.
Yeah, so like the NADH and like the what's it called again? The FADH2 are let me see. They're like used as electron carriers in the electron transport chain, yeah. And they transfer electrons from the citric acid cycle to like the electron transport chain, which like ultimately leads to the production of ATP.
Explain how the ATP is made at the ATP synthesis.
Hello, mate. So, I'm here to talk to you about ATP. So, you're thinking, this ATP stuff, it sounds great and all that, but how is it actually made? Well, it's made here at this funny little thing called an ATP synthase, right? Now, my professional research notes are right here, so I might read off them a little bit, right? So, it's made through a process called chemiosmosis. I just had a little bit of an aneurysm. All right, so this process involves the movement of protons across the inner mitochondrial membrane. So that's this area right here, right? Which creates a protein gradient, right? The energy from the proton gradient is used then to power the ATP synthase, right? So by then running through protons through it, right, we can create the magical thing we know as ATP.
And this is your interviewer, Nad, signing off.
G'day, mates. This is Mitochondrian Mike signing off.
Yeah, so like endothermic's like throat is like scorched from all this talking because Nat over here asked all these questions that I don't give a crap about, but yet she being stupid. So like this is endothermic.